we're going to take a look at vertex form of a quadratic. So what we will do is we'll try to relate it to a form we've seen before, where we use y is equal to ax squared plus bx plus c. But I'm also going to relate it, I believe you guys have started working with function notation, is that right?
Yes.
Okay, so here's our standard form. And then function notation is just a little bit of a different notation. Instead of writing y, we essentially name the function. We're calling this the function named f. Okay, you can use any letter. It could be g at x, it could be h at x, it could be happy face at x. Doesn't matter. It's a name of a function. So they happen to be calling it f so that you can remember that, oh yeah, this is function notation. And then the reason they write at x is what they're doing is defining what variable is in this equation. So if we take a look here, it looks like currently there's tons of variables. It looks like we have an a, a b, and a c, and an x. But that's not the case. What this actually is we have a function, the variable in it is x, and the generalized form of this has an a, b, c because they stand for numeric values. So the only true variable in here is x. With function notation, I could say f at xy, and then I might have an equation like this, and in which case there are two variables in it. That's the idea of what function notation is. Now, you really don't work with multivariate equations. We really only work with single variable equations, but that's the purpose of function notation. And we'll start to work with lots of different functions, and we name them different. We'll call one f and another one g and h and I. We'll use lots of different names so that when we talk about them, it's easy to navigate the mathematical page and figure out which equation are we speaking about. So let's bring this back down here. We've digressed a little to talk about functions, but we have f at x is equal to everything we have here, ax squared plus bx plus c. This is our standard, or the general form of a quadratic in standard form. So we're going to put that down, okay? Standard. Now, standard form is really nice. It's a polynomial separated. It's got 3 terms. In terms of graphing, not wonderful. It doesn't give you a lot of information. In fact, the only real graphical information we can visually see from this is the y-intercept is actually c, okay? So whether you've been shown that or not, whatever this is, that's actually what the y-intercept is. So that works out. That part's nice. And then you have another form, okay? We have this form, x minus, and usually they use an h and a k. Let me see if you've seen this before. Now my colors are going to be similar, but the variables are different, so they technically mean different values, okay? Have you ever seen this form before? Okay, this is called vertex form. It can represent the exact same equation. In fact, notice I called it the same function. In other words, we're representing the same function. It's just in a different form, okay? So we have a standard form and we have a vertex form. The reason we use these different forms is there's advantages to each. The standard form is nice, especially if we start going into calculus, if we have to derive something, that works out really nicely. And it can tell us the y-intercept. But for graphing, that's it, only the y-intercept. Vertex form is really helpful for graphing because it hands us a lot of information. In fact, it tells us that our vertex, okay, our vertex is equal to the x value of the vertex and the y value of the vertex happen to be our h and our k value. So that is why we visually rearrange into this form, is that I can look at it and whatever this number is, that's the x value of the vertex. Whatever this number is, that's the y value of vertex. Now, in general forms, it's sometimes hard to make sense of this, so we'll do some specific examples so that we can piece this idea together, okay? The only other thing I do want to draw your attention to is notice that there is an a in both. That number is the same. And I believe you did factored form at one point, right? Okay, so factored form, f at x is equal to x minus, do you guys use s or r or t? I can't remember. You guys have s and t. Okay, so you have like an s and a t. This is also there. This is the only numeric term that actually stays the same throughout all of them, okay? And this is the factored form. We could go into an entire lesson about the purpose of having these 3 different forms and how to move between them. And that's what all of your quadratics is going to be, is really, I'm in one form, how do I go to the next? Because it tells me some information. How do I go to the next because it gives me some more information? And then how do I go back? You're going to learn that this is the overview of all quadratics. But in this one, we'll focus on the vertex form. So let's say we're given an equation, and they've given it to us in this form. First thing we need to recognize is what form is something in. So we'll have x, let's say, minus 2 squared plus 1. Okay. My first question to you is, any idea what form this one is currently in? That's right, this is in vertex form. So because it's in vertex form, what I'm going to do is I'm going to put the general formula above it. Okay, so we have that a value, we have an x minus an h value, and we have a k value. So visually, why is this helpful? It's helpful because, like we said before, the x value of the vertex and the y value of the vertex are actually just the h and the k value. So our very first challenge here is, can we identify what those are? Well, my h value is 2. But notice that there's a negative here. Because there's a negative h, if there's a negative here, we're actually dealing with positive 2. Similar to factored form when we're looking for those roots, same thing happens with the x value of the vertex. While the k value, it is what you see. The k value is 1, therefore that value is 1. So if I was to graph this, I know that that is the coordinate of my vertex. That's what's so nice about this form. I can visually see it. And let's see, I'll put a little rough graph, I should say. If I had to draw this, I would say, okay, well, I have a vertex at positive 2, so we'll go 1, 2, and positive 1. Here we go. There's my vertex. And now this tells me if it's vertically stretched or compressed, which is the same as in our factor form. And it is. It's vertically stretched by a factor of 2. So if I was to draw this, I'm not sure if you're familiar with it, we go over 1. Normally we go up 1, but because we're being stretched by a factor of 2, we'd go up 2, over 1, up 2. If we go over 2, we're supposed to go up 4, times 2 is 8, so it goes up really high from the vertex. So we go over at 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is vertically stretched quite a bit. Okay, and I'm just going to do my best to connect the dots here. Ooh, not so good. But that's the general idea of what we've just made. Not a great graph. What we want to do is I want to show you it. Other way. There we go. I'm going to show you in this form here. Actually, we can write function notation in Desmos too. So we had 2, x minus 2, I believe, squared, and then plus 1. Did I write squared in our forms? Yeah, I did. Okay, good. Notice, there it is. There's our vertex, 2 and 1. Exactly what we showed here. And if this a value had been 1, I'm just going to show you the difference between the two of them. I'm going to change that number to 1. See how the red one is vertically stretched? It looks like it's being pulled from the middle. And that's the idea, that instead of going over 1, up 1, so we would go over, what value am I at? I'm at 1. So go over 1, up 1. So here we go, 3 and 2. So go to the right 1, up 1. In this course, it went over 1, up 2 in this case. So it has a vertical stretch of a factor of 2. That's the general idea of vertex form. Now, there's a heck of a lot you can do with vertex form. For instance, how to change from standard to vertex. There's an algorithm for it. We usually call it completing the square, or to go from factored to vertex. But really, my goal here is just an introduction to it. I want you to be aware of the purpose of vertex form and how we can visually look at it, plot a vertex, and then get a rough graph, not my best drawing there, a rough drawing of what this graph will look like.